So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? Perfect. Thank you so much for the confirmation, everyone. So my name is Neeraj Kheria, and I have been working in this IT industry for more than 13 years now. So we have gathered for a discussion on natural language processing. So the main agenda for today's session, we are going to talk about the evolution of human language, what exactly we mean by text mining, and what exactly is NLP. Then we are going to talk about the types of ambiguity in NLP, the type and applications of NLP, and what exactly we have as a part of text reading procedures. What do we mean by tokenizations? And then what exactly we mean by Tgrams and Ngrams and bigrams, and how the named entity recognition works. So this is what we are going to focus on as we proceed further with the session today. So let's get started. So if we talk about the evolution of human language, then first of all, if you go back to Stone Age, then again, there would have been a discussion. Let us build a language, and how exactly are we talking if we don't have built any language yet? So again, language, a way of conversation always had been there, but there have been different ways of conversing with the other being. And with time and with the difference in cultures, the different languages were evolved with their own literature. And since then, we have seen there are more than 7,000 varieties of different languages that are spoken all around the world, which are driven by their own rules. That they have their own syllable, we have their own grammar, and these language, and even a single language, for example, even English, it has multiple dialects. Even the different languages, they have multiple dialects, and that's why they are more than 7,000 plus languages all around the globe. And then if we talk about the text mining concepts, then text mining or text analytics is basically a process of deriving meaningful information from natural language text for further analysis using NLP. NLP refers to natural language processing, and text mining usually involves the process of structuring the input text, deriving patterns within the structured data, and finally evaluating and interpreting the output. So basically, before we can use any language, we have to make sure that we are able to understand it, right? So the same concept is also applicable to any system as well. Before we can start conversing in any language, we have to make sure that we are training the system. If we are building a system for working in any language, where we have to make sure that we are training the system for using that particular language, right? And that exactly is what we have text mining for. So using text mining, we can simply define the structure of the input text. What exactly is the structure? What is the pattern of that text? And especially if we are giving the input in the format of structured data sets, so we have to specify all the parameters, and then that is referred as text mining. When we are extracting text from a given structured data sets, and then we start evaluating its order. Now, the need of text mining. So with the advancement of technology, most of the data, approximately 85%, is in unstructured textual format. So let's say here we have data in the format of JSON, we have JSON data, we have XML data, which is not highly unstructured, but again, they are mostly, we can say semi-structured to unstructured data set. And the 85% of data being generated today, they are all unstructured to, we can say semi-structured data sets. And these are not databases, so we cannot run any kind of SQL query on these type of data because that is not possible. So we have to make sure that we are training the system to understand the context and meaning for the data by using something called as text mining as well. So better techniques and algorithms are required to extract useful and interesting information from large amount of user-generated textual data. And hence the area of text mining and information extraction came into picture, and it simply helped us in extracting interesting and useful information as per the requirement. So we know there are more than 4 billion active users in the world, and there are more than 1.1 billion active websites, and there are more than 120 billion emails that are sent on a daily basis, and then there are almost 2.6 billion searches which happens on a daily basis. There are more than 2.4 million blog posts done on a daily basis, and there are more than 340 million tweets that are done on a daily basis. And this is a humongous amount of data that needs to be processed. And if you want to understand the sentiment, if our goal is to perform some kind of sentiment analysis, or we want to understand the trends of the topic going on, then we have to, first of all, extract the meaning of this particular, like we can say, all the tweets being done, and not just in one language, but across different languages, so that we can understand what exactly is being talked about, and then we can use it for our advantage. Same concept is also followed by Twitter. So in Twitter, we have something called as trending topics. Now, Twitter uses the component of NLP in order to understand what is the topic that is being talked about, and how exactly, what is the frequency of it, and in which context they are being talked about. We can say, some good things are being said about that particular topic, or again, it is becoming infamous. So these things have to be closely evaluated to make sure that we are making a right prediction out of it. And that exactly is why we need to have text mining done. Now, if we talk about natural language processing, so before we move on, okay, now if you talk about natural language processing, then it is basically a part of AI which deals with understanding of a human language, or we can say a natural language by a program. That exactly is what we have NLP for. So using NLP, we make sure that the system is able to understand what exactly is the context in which the commands are being given, what is the sentiment behind it, so that we can understand it better to process it much better. If we talk about the history of NLP, then in 1971, the DARPA starts working on the first speech project, as it was the first body to work on the speech recognition system. In 1975, tech later known as hidden Markov models proposed IBM. Because, again, it was proposed for the first time in 1975, and IBM began working on speech recognition system afterwards. In 1978, the Texas Instruments releases Spark and Spell. So Speak and Spell, again, this was introduced as one of the major devices using the basics of natural language processing part. And then in 1982, Gaussian mixture models start being used for speech recognition. In 1986, researchers began experimenting with neural networks, and then in 1994, Dragon Natural Speaking, IBM via voice was introduced. In 1985, Microsoft introduces the first speech tools in Windows 95. In 96, SRI International deploys interactive voice response software. And then in 2001, Microsoft introduces Windows and Office XP speech using SAPI 5.0. And then in 2007, Microsoft releases mobile voice search for live search, now known as Bing. In 2010, Microsoft simply introduces Kinect for Xbox, so that the users can interact directly with the gaming console via their body movements, and also via their text components as well, via the speech as well. And then in 2011, Apple introduces Siri for iPhones. It was first time released. And then in 2012, Microsoft makes deep learning breakthrough, and Google was now introduced. The Google Assistant was introduced later after introduction of Siri. And then in 2014, Microsoft introduces Cortana personal assistant, and in 2015, Microsoft makes Skype translator available in German, Mandarin, and other languages. So we can see here again, IBM and Microsoft, they have been doing really good work in terms of advancement of this technology, and they have made sure that this is well integrated across the entire solutions as a part of history for natural language processing. Now, if we talk about the demand for natural language processing, then the world puts out as much as 2.5 exabytes of data every day, which means 90 years worth of high definition videos, or we can say 530 million songs or 150 million iPhones. So companies are frantically looking for effective means of mining the gold rush of data, and NLP is one of the most used ways. So until unless now we have this humongous amount of data being generated, so until unless we have an effective way of harvesting this information, we won't be able to move forward, because when we have this volume of data coming in, then until unless we use it for further analysis so that we can improvise the current system, we can improvise the content for the end user so that they see the content which they are more interested in. We can use this for delivery of the ads more effectively, and that too to the right set of audiences. So until as we have these kind of setup done, we won't be able to move forward, correct? And that's why we have to take the help of NLP for understanding the context in which these data sets are being generated, right? And first of all, if you talk about the process here, then first of all, we have text in. So now under text in, we can see we have, for example, say here we have Brazil makes number 5 in the list of countries by population. Suppose, let's say this is what? This is simply a news that has been posted on Twitter. And suppose here we have the term, the Negara, again, or we can say lady mother of the state is used for wife of the president of Indonesia. For example, first of all, if we talk about the first text here, Brazil makes number 5 in the list of countries by population. So now again here we can define the data out as in the countries with the largest population. We can define Brazil and then we can put it on number 5 as a part of the context in which this message has been read. Same way we have the T Megara, which is lady or mother of the state, is used for wife of the president of Indonesia. So now here we can, the country first ladies can be extracted. For example, here we have, so for example, here we have the spouse, we have for, again, for US and for Indonesia, again, by what name they are referred as. So here we can see the context, and plus we can derive the information from the post that has been done to even to cross check as well, because this is also used for checking for the facts, if whatever has been posted, if that data matches with the facts or not. And if they do not matches with the fact, then that is going to be considered as a fake news as well, because this is also one of the integral components which is useful for combating the fake news mechanism on social media platforms. And same way, like we have another post as Game of Thrones is an adaptation of a song of Ice and Fire, George R. Martin's series of fantasy novels, and it ranks 4th among the IMDb top rated TV shows. So again, we can cross check this information from the IMDb top rated TV shows based on the post that has been done. So basically here we are looking this for, again, making sure that we are able to match the data, and plus if something has been updated in terms of feed, something is going on, then based on that, other data pointers can be uploaded can be updated as well. So these all pointers are being available out there, and we have to make sure we are able to process it as quickly and as effectively as possible by using the components of NLP. So now if you talk about, again, segregating the different tasks here, now for example, here we have the first group. So here we have group 1. So here we have defined, now in group 1 we have cleanup, tokenization, we have streaming, we have stemming, we have lemonization, we have parts of speech tagging, query expansion, parsing, topic segmentation and recognition, and morphological segmentation. So again, these are different groups in which NLP is being used. For example, if we talk about the concept of morphological segmentation, again, based on different contexts, we are going to interpret the system, and that's how we are going to club them together in terms of NLP. And if you talk about stemming, then stemming is what? Stemming is basically a process of reducing a word to its word stem, that again that we can use for finding the suffixes and prefixes so that the root of the words can be known. So basically, now stemming is one of the core components that are used in the search engines For example, if you're talking about Google, again, stemming is used for understanding the context in which the queries are being generated, and that with the highest amount of accuracy possible. Same way, we have second group of user, for example, where we are using NLP for information retrieval, for relationship extraction, named entity recognition. First of all, we have information retrieval. Now, you must have seen that in a simple example is now we have voice-based search options available for Prime Video and for Netflix as well. For example, if we are using Echo device by Amazon, then we can simply press the button for allowing us to speak, and whatever we have, for example, if you're looking for a specific movie or we are looking for a specific movie or show for any specific actors or with the name of the movie defined. So again, that is what is being used for making sure that the information base which has been stored in the database based on the user input that is going to be retrieved as quickly as possible. The relationship extraction, that means if we want to relate one data with the other. And again, this is used for increasing the accuracy of the search results. So if we have asked for a movie for a specific actor, then it is going to fetch the list of all the movies. For example, comedy movies. First of all, it is going to look for the list in comedy movies, and then it is going to match it with the actors list as well. So again, for the effective relationship extraction, the named entity recognition, sentiment analysis, to understand the context in which the commands are being given, and then to understand the sentence boundary disambiguation. So again, in which context they are being given, we are going to use it for understanding the text similarity as well, then for conference resolution, for world sense, and for disambiguation as per the requirement. And then same way, it is also used for machine translation. The most effective use for machine translation is Google Translate. Now we know that machine translations, they are not as accurate as the human, because machine translation is still only 50% accurate, because again, the grammar and other components cannot be matched as what we can do with the human users, right? So we have to make sure, again, even if we want to use such a service like we have Google Translate, we can use it, and whatever we type in, that's going to be translated to any other language pair with the, we can say still the, no, it is not going to be grammatically correct, so it cannot be used for the professional level, but again, still the users will be able to understand the context in which they are currently reading the command. So that is going to be helpful, right? So this is where we, again, this is all also currently running on top of the NLP engine in order to understand the context in which the commands are being given, and again to make sure that the right set of conversion is being given to the end users. All right, and suppose let's say here we type in as welcome to Edureka. Again, now suppose here we want the sentence to be converted to any other language pair, then we can see that the same sentence is going to be structured. Now this is useful for simple plain content, but still the accuracy for the professional level is not being achieved, because at the end we have, now in a language we have different words that are used for different contexts. So again, where to use which word, how they have to be used, that is what humans can have a control more than the machines. But still, if we are using this for personal level, for just for our own understanding, or when we are out there in some other countries, then we can use this to understand the context, we can say the road signs, the commands which are being written in that particular language pair. It can be useful for understanding those kind of context. Again, this is one of the most widely used case for NLP. Say we have automatic summarization. So if we have a book, now we want to generate a summary out of it. So again, we can either hire an expert who is going to study the entire book, and then that person is going to give us the entire summary of that book, right? So that can be one of the use case, or we can use the NLP module, so that based on the understanding of the content, for suppose for any paragraph or for any book, we can generate an automated summary that we can allow the end users to customize further, so that they don't have to invest the time in writing the entire summary from scratch. So instead of doing that, they can simply generate a summary that can be used for further optimization. That can also be done here. And then we can use it for quotation answering, for dialogue system, for image captioning, and for paraphrasing as well. Now, a good use case for it is also in the context for auto generation of the subtitles as well. Now, if you talk about subtitles, now you may have also observed this when we are watching any YouTube video. For example, if we go to any YouTube channel, and now, for example, if you're looking to understand any context, or we can say we want to simply trigger the subtitle. For example, suppose currently we are on the channel. Now we want to understand, we want to enable the correct. So here we can suppose here we can define playback speed, or here we subtitle. So now, as you can see, currently the subtitle has been on, right? So we can see this is if we enable the subtitle again, whatever the now this thing has not been enabled by default. So whatever this speech is being currently available in the video, the automatic subtitle is going to be generated out of it. So there is no manual involvement here. Now this subtitle is going to be automatically generated by the system, all by using the context by understanding the context in which each and every command point, the command, or we can say the speech is being said, by understanding the exact context, and that's how the automatic subtitles are also being generated as a part. And again, what we can do basically here, we can use the NLP to generate these subtitles automatically so that it becomes easier for us to review it and correct the grammar and any other language which has been generated by the current language system here. So that's what we can generate here. So there are multiple use cases for NLP in almost every solution that we may think of. So let's come right back. Now, next we have the basic structure. Let's understand the basic structure for NLP application. So the application interface for using with the, now first of all, we have the application interface for your users to interact with the application. Then it is going to translate the user queries into information for appropriate responses. And then we are going to contain the database of information needed to respond queries of customers' request. And then it is going to contain the interaction history of chatbot with the end users. That's going to be the endpoint of delivery hub. So now let's discuss on the components of NLP. So if we talk about the different components available in NLP, the first component is the input sentence. So at the end, we have to train the system by using the entire paraphrases and the data set, right? So here we have the input sentence. Now, once the sentence has been taken into the system, then we have to work on the morphological processing part. Then we come down to the syntax analysis. And then again, in terms of syntax analysis, we have lexicon, and then we have to understand the grammar as well. And then in terms of the semantic analysis, we have to define multiple semantic rules. So basically, if we talk about the main purpose of semantic analysis, then we do that to draw the exact meaning, or we can say the dictionary meaning from the given text that has been provided. So the work of semantic analyzer is to check the text for meaningfulness. Now we already know that we had discussed that we have lexical analysis that also deals with the meaning of the words. Then we may have a question how this is different from the lexical analysis. So lexical analysis, as we had discussed, it is based on smaller tokens, but on the other side, semantic analysis is focused on the larger chunks. So we can say we have big words. So that is why semantic analysis can be divided into, again, further two parts. Like we have studying the meaning of a single word. For example, it is the part of the semantic analysis in which we study the meaning of individual words. And then we have combination of individual words. So in second part, the individual words will be combined to provide meaningful, we can say meaning in a given sentence as a part of semantic analysis. And the most important task of semantic analysis is to get the proper meaning of the sentence. So for example, let's say if we talk about a simple sentence as in, suppose Edureka is one of top training providers. Suppose we have Edureka is one of the top training providers. Suppose here, if we talk about this sentence, right? So here we have to perform the multiple semantic analysis as well. Now in this sentence, the speaker, now, for example, any speaker who is giving the statement, the speaker is talking about either about again, now, when we talk about Edureka, again here we have to understand which particular sentence this is going to be referred as. For example, suppose if we talk about John is eating. Suppose here, now, if we type the same sentence in the search engines, now the search engine has to understand which John we are going to talk about. For example, suppose, let's say if we talk about any other statement, for example, if we talk about any popular personality, for example, suppose if we talk about Obama, Obama has been walking down the street. Now, first of all, we have to understand who exactly is Obama. For example, if we are talking about the President Obama, or if you're talking about any other person, right? So we have to understand what exactly is being referred here, and that's why the job to get the proper meaning of the sentence, have to make use of semantic analyzer to understand the context in which the statement has been given, and that exactly is what semantic analysis is, and that's why it is also an integral part of natural language processing. So now let's talk about ambiguity. So if we talk about ambiguity, then there are three types of ambiguity available. So now again, this can be one of a small example. Let's say here we have call me a cab. Now this is basically a phrase that we use when we are asking someone to bring us a cab, right? So now basically if we go with the default language structure in English, if someone asks us, okay, call me a cab, so then the reply could be you are a cab. Okay, you are a cab, right? As per the default language structure. But again, here we also have to understand the context in which the commands are being given, and that is what we do by using that's what we understand by taking care of ambiguity there. All right. So that's why there are three types of ambiguity available. We have lexical ambiguity, syntactic ambiguity, and then we have referential ambiguity. So in terms of lexical ambiguity, the presence of two or more possible meanings for a single word is referred as lexical ambiguity. It's also called semantic ambiguity or homonymy. Examples: she is looking for a match and the fisherman went to a bank. So again, these two are the contexts, again, basically which we are going to process by using lexical ambiguity. Now, when we say a match, again, that doesn't mean a sports match. And when we say the fisherman went to the bank, that doesn't mean that we can say a complete banking institution. It is simply means that they have gone to the bank of a river, not to the institution, right? So we have to understand the context in which the statements are being given, and that is generally a part of lexical ambiguity. When we have two or more possible meanings of a same word. Then we have syntactic ambiguity. So the presence of two or more possible meanings within a single sentence or a sequence of words are a part of syntactic ambiguity. And also it is called as structural ambiguity or grammatical ambiguity. For example, we have a sentence, I saw the man with the binoculars. Now the ambiguity is who has the binocular, me or him, correct? Right? So I saw the man, this has two different meanings. So we saw a man carrying a binoculars, or we saw the man with binoculars that we were using, correct? So again, here we have an ambiguity that we have to understand. Same way, we have, I watched her duck. So now again, we have a ambiguity. That means does she have a duck that we watched, or we watched her, again, simply duck out of the way. That means the same sentence has two possible meanings. And that is what we have to understand by using syntactic ambiguity. Then we have referential ambiguity. So it occurs when a word or phrase in the context of a particular sentence could refer to two or more properties of things. So for example, she is a big opera star. Now the ambiguity is it is not clear if big means fat or famous, right? It can mean two different things. So again, this is what we have to refer as a part of referential ambiguity. So next we have the most popular Python library for NLP, which is called as the Nltk. So let's understand on that. So first of all, before we can get started, if you want to set the Nltk platform, then we have to use the pip library to install Nltk. Then only we can get started as one of the main libraries used in natural language processing. So now let's say if we are going to install Nltk, we can use any of the platforms. For example, if we are using Anaconda locally, then we can use, and now here we can use the pip library from Anaconda. And then by using the pip library, we can simply install Nltk as simple command statement. And this is going to install Nltk being one of the main libraries used in natural language processing from the pip, we can say pip library package manager. So basically here it is going to simply install all the library package managers here one by one. So if this has already been installed, then we can simply start working on NLTK to use it as a part of library that we want to use for natural language processing. And when we have once we have properly installed and configured NLTK, then we can make use of it when we are in our notebook, or if you want to get started working on any of the online code editors like we have Colab, then we can simply import this NLTK library and then we can get started. So if we talk about the concept of tokenization, so tokenization is what? It's simply a process of breaking up text into many small pieces where we can work by separating words using space and punctuation. So for example, we have let's, again here we can simply break the word let's into let us, right? So here we have let and apostrophe s, and then we can simply break down the words as NYI into NY and then I. And then we can start deriving meaning out of it as a part of tokenization. So basically, we use tokenization to break a complex sentence into words, to understand the importance of each of the words with respect to the sentence, and then how to produce a structural description on an input of a given sentence. That is what we do by using the concept of tokenization. All right. And then we are going to produce a structural description of an input sentence as a part of tokenization use case. So then we have bigrams, trigrams, and then we have n-grams. So if we talk about trigrams, then these are the tokens of three consecutive written words known as a trigram. Then we have n-gram is basically token of any number of consecutive written words known as n-gram, and tokens of two consecutive written words are known as bigram. So we have n-gram, bigram, and then we had trigram. So NLTK also allows us to tokenize phrases containing more than one single word as a part of NLP structures. So if we talk about tokenization, then basically it simply involves separating a piece of text into smaller units called as tokens. And then if we are taking in two tokens, then that is going to be called as bigrams. If we are referencing to three tokens, then that is going to be referred as trigrams, and so on. So here tokens can be either words, they can be characters, they can be multiple sub words as well, depending upon setup or depending upon the phrase that we are going to analyze. So for example, let's say if we talk about this is a sentence. Now here we have structured the entire part into equal tokens, and this is referred as unigrams. And if we have combined multiple tokens together, for example, here we have two tokens. This is a part of single token. As you can see here, we have grouped it together. We have this is a part of a single token, right? So here we have grouped two different tokens together. Then we have is a again grouped into two, and then again we have a sentence grouped into two. So these are what? These are referred as bigrams. This is a and a sentence. And then we have three words combined together. For example, this is a and is a sentence is basically a part of trigrams. When we combine multiple tokens together. 3 tokens together, then that is a trigram. 2 tokens together, then that's a bigram, and a single token is referred as a unigram. All right, so next we have stemming. So stemming is basically, first of all, few words like study, studies, and studying stems into study, which is not an English word. So basically, we have to work on normalizing words into its base form or root form. For example, the words fish, fishes, and fishing all stem into fish, right? And the result may not be the root word. The common types of stemming algorithms are we have Porter, Lancaster, and then we have Snowball. So these all are different algorithms used in under stemming. So for example, let's say if you want to work on Lancaster stemmer, for example here, now stemming using Lancaster stemmer, we can import NLTK library, and then we are going to import Lancaster stemmer from it, and then we can define the list for Lancaster stemmer. And for words in word system, we can define any words that we have. For example, we can see the stemmer stemmed all the words, like we have give, giving, given, gave. So again, we have stemmed all the words. As a result of it, we can conclude that Lancaster stemmer is more aggressive than Porter stemmer. So the use of each of the statements depends upon the type of task we want to perform. For example, if we want to check how many times the word give is used above, we can use the Lancaster stemmer. And same way, suppose if we talk about Porter stemmer with NLTK, suppose here we can import the NLTK library, and then we are going to use a stemmer for word having. So now if we use a Porter stemmer to stem a list of words, then we can here we can define give, giving, given, gave, and then we are going to print the stem words. We are going to see the stemmer removed only ing and replaced it with a simple e as a part of the statement that we have defined by using Porter stemmer. So depending upon the requirement, here we can see here we have the stemmer word removes only the ing part as compared to Lancaster stemmer that we have used. Next, and suppose let's say if we are using any of the platforms, for example, let's say here we are going to make use of any, or let's suppose here we are using PyCharm as a part of the architecture here. So here if we are using PyCharm, then here we can install any library that we want. For example, if we want to install NLTK, then we can install NLTK as well as part of the requirement. So here we have, for example, if we want to import any of the libraries here, then we can define all the parameters. For example, now if we talk about the Porter stemmer implementation part, then we can either use the Anaconda CLI, we can either use a Python CLI, or in case we have the access to any of the IDs, like we have PyCharm. So we can open a PyCharm, and here we can start creating a new project like this one. And here we can simply start using the NLTK stem, and here we can import, let's say here we can import Porter stemmer for getting started. So here we can define Porter stemmer. So now here you have to define from this NLTK stem library, we are going to import Porter stemmer, and then we can define a simple variable. Suppose here we can define PST for Porter stemmer that we are going to make use of. And then we can, now here we are going to use a stemmer for the word having. For example, here we can define pst.stem, where we can define a word, suppose as having. And then we can use a Porter stemmer to stem a list of words as well as part of the requirement. For example, if we run this entire statement, then we are going to get a simple result. And same way here we are going to run a statement. For example, suppose here we define a collection of words. For example, let's say instead of pre-system here, suppose here we define words to, or suppose here define words, and here we define a simple array of words. Suppose here we define, first of all, we have give, then we have given, then we have giving, then we have words as gave. Suppose here we have this array of words. So now here we can define for words, or suppose here we define words underscore stem. Now here we can define for words in words underscore stem, we can print the words included, and then we can concatenate this with, now here we can add a simple colon so that we can stem the words out of it. So here we can define pst dot stem, and then we can include the words that are going to be listed down here, whatever word we are going to stem out of the given array of words. So we can define this kind of Potter stemmer. So as you can see, if we run this, we can see the words have, again, we can see the stemmer word removed only ing, and it simply replaced it with a simple e itself, right, as a part of stemmer. So that's how we can work with the Potter stemmer. And then we have the Lancaster stemmer, where we can stem all the given words. For example, instead of using Potter stemmer, as a result, we can use Lancaster stemmer, which is more aggressive than Potter stemmer. For example, if we want to find the entire root words, so there we can make use of Lancaster stemmer instead of Potter stemmer. So for example, let's say if we use the same use case, but again here we use Lancaster, let's do one thing. Let's create a new file to use it as a reference. So let's say here we use a new file, and here we import same library as Nltk dot stem, and then we are going to import Lancaster stemmer here, Lancaster stemmer, and then we can define a list where we are going to use Lancaster stemmer, and then here we can define for words. Let's do one thing. We define the words here as well, because again at the end words also need to be specified here. So we can define the words here, where we can define words underscore stem, and here we can define the same array. Let's copy the same thing that we had defined here so that we can see the actual difference between Lancaster stemmer and then what we have done by using Potter stemmer. So here we can define the same words, and now we can define Lancaster stemmer. So here we can define for words in words underscore stem that we define. We are going to print the words, and then we are going to concatenate this with a simple colon as well, and then we are going to define from the list we are going to stem out the words by using Lancaster stemmer. So now if we run this statement, we can see it has given us a simple root word. That means we can see the stemmer stem all the words. As a result of it, we can conclude that Lancaster stemmer is more aggressive than Potter stemmer that we have used in our other hands-on demo. So that's what we have as stemming. Next, we have something called as lemmatization. So basically, lemmatization is when we are grouping together different inflected forms of a word, that is called as lemma, and somehow similar to stemming, as it maps several words into one common root. And the output of lemmatization is a per word. For example, a lemmatizer should map gone, going, and went into go. So although we have went, but went is not going to be stem into v. It's going to step went, or it is going to be stem into go as a part of lemmatization. All right, as a part of lemmatization available here. Then we have named entity recognition. So basically, if you refer as named entity in recognition here, then data extraction task for automatically finding and sorting into different categories like people, date, time, location, person, cardinal numbers, ordinal numbers, and organization in text across multiple languages is done by using NER, or what we refer as named entity recognition. So we can extract different data pointers from a given phrase so that we can sort the data later on. For example, let's say here we want to get a summary of the complete text, and we want to segregate this file based on some selective words. Then we can make use of NER. For example, we want to find out this report is for which city. Then we can quickly identify the city from the given report. We want to find out which context is, for example, which city or for which particular report this is being generated. Again, we can make use of this kind of NER. All right, so let's say we wrap it up for today, guys. Thank you so much for joining, and have a great day ahead. Take care. Bye bye.